Imagine having backpacked the serene, towering forests of the Rocky Mountains, where the air is crisp and the ground is blanketed with a tapestry of aspen leaves. But along your journey, you noticed certain trees in certain locations were of a distinct size, but in other locations, the size of those same species of trees were apparently different. While you might be aware that climate resources such as temperature and precipitation are significant factors influencing their growth, researchers have discovered some intriguing, lesser explored elements explaining the range of behavior in the growth of trees, elements that could be crucial for determining the impact of climate change on forests. So, what are these mysterious influences, and what should we be considering when managing our forests in the face of a changing climate? Here, we dive into a fascinating study about the secret lives of trees that attempts to unlock the mysteries of how they might adapt and survive in their uncertain future. Researchers at Colorado State University and the Cary Institute of Ecosystem Studies have discovered something very intriguing about trees. In recent decades, climate change has been rewriting the rules of nature. And just like people, trees have their own ways of coping with stress. Whether they're dealing with fluctuations in climate, competition from neighbours, or differences in site conditions, their versatility has allowed them to adapt to stresses and continue to grow in various ways. This dynamic dance of factors influencing tree growth is what researchers are eager to decode. The good thing is, trees have been keeping a secret diary of their lives, etching their stories in their tree rings year after year. To dive deep into the mystery of tree growth, scientists have turned to dendrochronology, the study of tree rings. By examining these rings, researchers can track how trees have responded to changes in temperature and precipitation over time. Scientists are now decoding these stories to understand how our changing climate is impacting forests. But here's the twist: tree growth isn't just about the climate. Scientists are finding that tree growth is often influenced by numerous factors, such as trees interacting with neighbouring trees, genetic differences within species, and oftentimes various factors interacting with each other. So how did the researchers sort through this messy web, and how did they acquire their data to do it? They went to 5 different testing sites from New Mexico to Montana, including the beautiful areas of Lincoln National Forest, San Isabel National Forest, Roosevelt National Forest, Bighorn National Forest, and Glacier National Park. These sites experience a decrease in annual temperature and an increase in precipitation when you go from south to north, which allows the researchers to see how trees respond to different site conditions. At these sites, they collected tree ring data. This data is obtained using an instrument called an increment borer, which is this thin, hollow tube that gets screwed into a tree. And when it gets pulled out, you can see the tree rings that grow each year, and this helps determine a tree's age. Don't worry, the cores aren't known to cause any damage to the tree because the borer is so small. For this study, the researchers only looked at the most recent 20 years of growth. The common tree species sampled were subalpine fir, Engelmann spruce, lodgepole pine, ponderosa pine, and Douglas fir. Now, one of the main variables the researchers were evaluating was the impact of neighbourhood competition on a tree's growth. Let me break down how they did this. Researchers would set up a boxing ring around a subset of trees and put boxing gloves on their branches and...
Are you kidding me?
Not actually. Instead, imagine each tree is part of a community, and how well each tree grows depends on its neighbours. The researchers used a special method to measure how crowded it gets around each tree, called the Neighbourhood Crowding Index. This index looks at how many trees are nearby, what type they are, and how big they are at particular study sites. The closer and bigger the neighbouring trees are to a specific tree in the site, also referred to as the target tree, the more the neighbouring trees are influencing the target tree's growth. They also looked at how the size of the target tree changes its sensitivity to this crowding. For instance, if the target tree is large, it might not feel the crowding as much as a smaller tree would. These different parameters help to determine how the neighbourhood around a particular tree influenced that tree's growth. Once the researchers had the tree ring data, the neighbourhood competition data, and the climate data, they could use it to create models to estimate the effects of tree size, age, neighbourhood competition, and climate on the growth of trees. And what the results revealed was anything but dull. To begin, the results showed a complex and nuanced relationship between tree growth and climate, which varied significantly by species and location. It turns out that all species responded positively to increases in annual moisture up to a certain threshold. And in regards to temperature, the study found that in severe environments, growth responses to temperature were non-linear, simply meaning that instead of temperature causing a constant proportional increase or decrease in growth, the proportion would vary. Additionally, researchers noticed temperature was affecting trees differently depending on their location. For instance, in northern cold locations, locations, trees responded positively to warmer temperatures, but in warmer southern climates, excessive heat hampered growth. This variability suggests that local site conditions significantly influence growth responses. Where the results really got interesting was in how trees were responding to trees around them. One might think that trees, with their serene and tranquil presence, live in harmonious coexistence. However, beneath this calm facade lies a fierce battle for resources. Surprisingly, the study found that neighbourhood competition played a critical role in tree growth. The net effect of tree competition on diameter growth was negative for all species studied, meaning the more trees have to compete for resources like sunlight and water, the more their actual growth becomes hindered. But the effects of competition varied among different species. For example, trees that are generally more tolerant to shade were only slightly affected by greater competition, but trees that require more sunlight for growth were more hampered by having more neighbours. For some species, competitive effects had a stronger influence on growth performance than climate itself, and to add to the complexity, combining the influence of competition together with varying climatic conditions contributed to further differences in levels of growth. This study underscores the profound complexity of tree growth, emphasizing the critical role of local site conditions and tree adaptations in understanding how forests respond to environmental changes. It reveals that predictive models must account for factors such as temperature, precipitation, competition, age, and geography to forecast forests' future accurately under global climate change. This study also highlights the importance of understanding the influence of neighbourhood competition on tree growth for forest management. Where monoculture forests can be more susceptible to environmental threats, understanding tree competition can inform management practices like selective thinning to enhance forest resilience and carbon storage. So the next time you walk through a forest, take a moment to marvel at the silent giants around you. They are not just trees, they are living chronicles of the Earth's climatic history, each ring narrating a tale of past conditions. And as we continue to unravel their secrets, we uncover not just the mysteries of trees, but also the keys to our own survival on this planet. As always, these are simplified summaries of published research articles. For more information about the details of the study, please reference the link provided in the description below. If you enjoyed this video and are interested in more simplified, fascinating insights in science, feel free to subscribe, like and comment for more videos. Thank you.